So if you are still wanting to use the longer formula, I've got it put in here so that you can use it already written in, but I'm going to just do this using the should have minus half. So I'm going to look at oxygen over here. Oxygen comes to the party with 6. So I need to be looking at 6 electrons here, minus it's got 1, 2, 3, 4, 5, 6 attached. And the other oxygen is exactly the same. Go to the next one. All right, so I'm going to look at this nitrogen right here. And so the nitrogen with all these extra numbers in here, it's hard to see. So with the nitrogen, actually, I'll just jump to one of the other structures. Let me jump to the structure over here. So nitrogen has 5 valence electrons, and then he's got 1, 2, 3, 4 things attached. So that's how come this becomes positive. Get a smaller diameter here. And then over here, this oxygen on the top right, it came with 6, and it has 1, 2, 3, 4, 5, 6 things attached. This oxygen came with 6, and it has 1, 2, 3, 4, 5, 6, 7. And then this oxygen is exactly the same. It's the same number of lone pairs. It's the same number of bonds. So this is also going to be minus 1. Now what you do when you have these formal charges is, like I did with this one right here, is you'll put, I'm going to write nitrogen right here really quick, like that. Is you'll put them like that. And then like this one is a minus 1 and this is a minus 1. Interestingly enough, this also should add up to the total charge. If your molecule has a charge, it should add up. So you'll notice that I have a total of 2 minuses and then I have a plus. So negative 2 plus 1 is negative 1. And jump on down to the next one. Again, I've got the long version of the formula there. So if I'm going over here with the oxygen, I've got, he comes with 6, and then it's got 1, 2, 3, 4, 5 things attached, plus 1. Notice it's got the little circle there. This oxygen is 6, and it's got 1, 2, 3, 4, 5, 6 things attached. This oxygen is 6, and it has 1, 2, 3, 4, 5, 6, 7 things attached. And it's minus 1. And again, notice that the 2 charges add up to being neutral, which is cool because the whole molecule is neutral. Scroll on over. All right, so this oxygen on top is 6. He comes with 6, and he's got 1, 2, 3, 4, 5, 6 things attached, and it's 0. This hydrogen comes with 1. He's only got 1 thing. Hydrogens are always 0. And then the carbon is 4 minus 1, 2, 3, 4 things attached, 0. Hopefully you're starting to kind of get the sense for it. So this carbon right here comes with 4, and he's got 1, 2, 3, 4 things attached. So it's 0. This oxygen came with 6, and it has 1, 2, 3, 4, 5, 6 things attached. And the other oxygen's the same way. So this sulfur comes with 6, and it's got 1, 2, 3, 4 things attached. You can tell this is not good. Really not good. We need to fix it. And this oxygen is 6 minus 1, 2, 3, 4, 5, 6 things attached, which is 0. This oxygen here is 6 minus 1, 2, 3, 4, 5, 6, 7 things attached, which is minus 1. It's kind of like he's owing, people are owing him electrons or something like that. Also, an issue with this one, well, this one isn't doing it. It's consistent because at least the charges add up. An issue with the next one is the charges are not even going to add up. So you can tell that the next one isn't going to be good either. So if I go into the sulfur, sulfur is 6 minus 1, 2, 3, 4, 5 things. That's plus 1. So yeah, someone else took one of his electrons. This oxygen up here is 6 minus 1, 2, 3, 4, 5, 6, 7, which is minus 1. Ignore that for a second. That's for something else. And all of those oxygens are all that. So all of the oxygens in this structure are minus 1. So notice we've got 1, 2, 3 minus ones and a plus one. So they all add up to being 2 minus, which matches, but that doesn't mean it's a good structure. We can actually make this one better also.